So let's go ahead and jump into LaTeX and type these up. So I'm going to stop sharing. Let's go into LaTeX. Actually, let me open up that. Give me a second. Just so we can have sort of the example side by side, and then we'll also have the LaTeX version on the side. So hopefully my computer cooperates. All right, so we're going to write these up in LaTeX. Let me zoom in. So let's do the first example. Basically, we had the building blocks. So the set notation, it looks something like we have x, which is our variable. We have a type t, and then a predicate, and then an expression. So the way you write this in LaTeX is you use a $sign for specifying math mode, and then you do s, and then basically these squiggly brackets, by the way, are reserved keywords in LaTeX. So if I actually do this, it's not going to show me like a set. So instead, you have to use the escape character, which is just a backslash, and then that will give you the set notation property. Let me zoom in a bit more. Okay, so we're going to use the squiggly brackets, and then again, we just have x of type t, vertical bar, r, and then e. So that's our basic set notation. And then we had this example of specifying all numbers that are less than 10. So let's do all natural numbers less than 10. So this would look like similar to above. We have a set, and then we do x. Now the way you state sort of the symbol for natural numbers is you do /math_bb, and then just n. If you put z, it will show like the symbol for integers, r for reals, and so on. So that's for natural numbers. And then we just have x is less than 10, and we just want the element x itself. And then that basically specifies what we have on the right. So other questions, and then I'll add the closing squiggly bracket. So hopefully it should be clear so far. Let's see. So then we also had, for example, the point. So we had the point example, or I guess we can do the quantifier example. We have basically, if you want to specify quantifier, you would do something like /for_all, and then let's use that point example. We have p of type point, and then we have p. If you want to state like the element of a symbol, so the member of symbol for sets, you use /in, and then p, and then basically we have inbounds point p. Okay, so any questions so far? And then usually what happens is if you specify like words within the math mode, it ends up looking a bit odd. So you can usually just end the math mode there and then just pick it off where you need it. So like something like that. Okay, other questions? Yeah, we don't need the second part. So that's for quantifiers, and then we can also have the existential quantifier. So existential quantifier. So that one looks similar. Instead of the for all, we just have the /exists. So for example, we had that mod 2 example. So let me find that. Let's see, these notes are a bit unordered. Yeah, so this one. So exists x, again, we can use /math_bb for the math notation. So that's for z, for integer. And then x is in L, it's a member of L. And then again, we just have this mod 2x equals 0. So that's our predicate, mod 2x equals 0. So that would end up looking like this. And let me add a line break here, just so it's more readable. So it would end up looking like that. So we're just translating our examples to LaTeX. So let's do another one that's slightly more complicated. Let's see. Let's do this one, the set of points that are on or within a circle. So this would look similar to the set example we've done already. We're going to have the squiggly brackets. Basically, we have x, y, r, and then these are real numbers. So we're going to use math_bb. We're going to use r for the real number symbol. And then we have x squared, so you just use sort of the hat symbol for squares. If you want a subscript, I believe it's underscore. And then you can wrap whatever you want in the subscript. Let me check that actually. Yeah, so that's for subscript. And then the reason you need parentheses sometimes, in this case you don't. Sometimes you need parentheses for subscripts because you might have more than one character. So you might have like 1, 2, 4, 3. So that's how you would specify subscripts. That's just a little aside. So you have x squared plus y squared, and less than or equal to is /LEQ in LaTeX. So then we have that, and then we're just going to have xy. And then we're going to close our bracket. So any questions about LaTeX or anything? Any questions? Otherwise, I'll continue. Looks like no questions. Let's see, is there one other example we can do? Yeah, so basically, if you want the set notation to show up, you need to use the / character in front of it. So notice that, for example, because the squiggly brackets are a reserved keyword in LaTeX. So for example, here, we use the squiggly brackets to specify sort of the arguments to this. You can think of it like a function, basically. You specify if you want R or N. So basically, the squiggly brackets are reserved keywords. So if you actually want to print them out, which they normally wouldn't, you have to just put a /. So when I want to print out the set, for example, I want the squiggly bracket, so I would put the / the backslash in front of it. So hopefully that's clear. Let's do that example of stating that all elements are distinct. That was this one. Stating all elements are distinct. So this would look basically, we have a for all, and then we're going to have I of type, it's going to have type integer. And then we're going to say that I is in, and then you can just map it one-to-one. In most cases, there's just like little things like the in and the quantifier, and then other things that you have to just know sort of the syntax for. But this would look something like this. S goes to s-1, and then we have a nested quantifier. So I'll go on the next line just so it's more clear. So for all j, so /mathbb, also of type integer, we have j is in I plus 1, and it goes to s-1, and then the predicate is that, I'll go on the next line again, si, and then for not equals you use /neq for not equals, and then sj, and then we close our parentheses. So let's compile that, and I see there's a comment in the chat. I'll take a look. Forgot to put the slash here. Okay, so that's what that looks like. And we didn't put a parentheses at the beginning. Oh, I see. This is what I missed. Yeah, thanks for pointing that out. So x squared plus y squared is less than or equal to r squared. And this isn't actually the right notation for tuples. I'll check after the tutorial how to get like the proper sort of the proper brackets for a tuple, but these aren't the correct ones. It's the angle brackets, yeah. So if you do /left angle, yeah, thank you for whoever mentioned that. Not a LaTeX expert, so just bear with me. So yeah, those are the tricks. So that's a proper one that you can use for tuples. And okay, yeah, so thanks for pointing that out. So any other questions? I'll give you guys a minute or so just to look that over, see if you have any questions, and then we can move on to our last bit. Double slash at the end. Oh, that's just for a new line. So if I remove that, notice that there's a there's a new line here. But if I remove that, it's just more. You don't have that new line. So that's just for readability. To make that a bit more clear, I'll just space it out just so you can see that this backslash isn't related to the set. Okay, other questions? Again, I'll give you a few minutes to look over it, see if you have any questions, and I'll adjust this. Okay, looks like no more questions. So now let's go ahead and implement one of these, like one of the specifications in actual code, and then we'll see why it's not always a good it's not always a good idea to basically just follow the spec blindly. So you have to take into account different factors when you're actually implementing things. So let me open this side by side with my editor.